Hello viewers, in today's class we are going to discuss yet another important and very conceptual problem from limits, right? And here we have to see whether the limit of this function when x approaches to 3 it exists or not, right? So we have to find limit x tends to 3, and here we have a signum of mod of x minus 3, right? So here we have the absolute value function, and this is divided by cosine of the absolute value of x minus 3, right? So here we'll see whether the limit of this function when x approaches to 3 it exists or not, right? So for this what we will do, we'll find out the right hand limit and the left hand limit. So here we'll make use of the definition of a signum function and the definition of absolute value function, right? So now let us first see the definition of signum function, right? So the signum function is defined like this, that is signum of say y is equal to plus 1 whenever y is greater than 0, right? And signum of y takes the value 0 whenever y is equal to 0, and signum of y is minus 1 whenever y is less than 0, right? Okay, now the absolute value function is defined like this, that is absolute value of y is defined as positive y whenever y is greater than 0, and absolute value of y is equal to 0 when y is equal to 0, and mod of y is equal to negative y whenever y is less than 0, right? So here I will make use of these two definitions to evaluate the right hand limit and the left hand limit. So now let us find out the right hand limit, right? So the notation for the right hand limit is limit x tends to 3, and here we'll put a positive sign, and we have the function signum of mod of x minus 3, and here we have cosine of mod of x minus 3, right? Okay, so now we'll here put x is equal to 3 plus h, right? So when x tends to 3, then obviously h tends to 0, right? And here h is a very important quantity, and h is positive, and it lies between 0 and 1, right? So h is infinitesimally very small, right? So now if we convert this limit in terms of h, then we can now write this limit as limit h tends to 0, and we have a signum of here we have a mod of 3 plus h minus 3, and in the denominator we have a cos of mod of 3 plus h minus 3, right? So now let us simplify this expression. So we have limit, and we have h tends to 0, and signum of here 3 and 3 get cancelled, and we have simply mod of h, right? And here we have cos of here also 3 and 3 get cancelled. We have cosine of mod of h, right? Okay, now see, here we have in the numerator signum of mod of h. Now here we cannot directly substitute here h is equal to 0, right? What we will do, will take signum of mod of h separately, right? So signum of mod of h is equal to positive 1. Why? Because see, h is positive, right? So mod of h can be written as simply positive h. So signum of mod of h can be written as signum of simply h, right? And this h is greater than 0. So here I will use this definition of signum function, right? So since h is greater than 0, so signum of h takes the value plus 1, right? So now this limit can be written as the limit, and here we have h tends to 0. So now signum of mod of h is simply plus 1, and in the denominator we have cosine of mod of h. Mod of h can be written as positive h or simply h, right? So now this limit is simply 1 over cosine of 0, right? So now we can take h is equal to 0 here, and cos 0 is 1, so we have 1 over 1, that is equal to 1, right? So the right hand limit of this function when x approaches to 3 is equal to 1, right? Now let us find out the left hand limit, right? So the notation for left hand limit is limit, and here we have x tends to 3, and here we'll put a negative sign, right? And the function is signum of mod of x minus 3, and here we have a cosine of mod of x minus 3, right? So when we calculate the left hand limit, we'll take x is equal to 3 minus h, right? And here again h is positive, and it is infinitesimally very small, and h lies between 0 and 1, right? So when x tends to 0 3, then obviously h tends to 0, right? So now the left hand limit can be written as limit h tends to 0, because for x tends to 3, minus we have h tends to 0, and here we have signum of mod of x minus 3. So for x we can now write 3 minus h, and here we have minus 3, and in the denominator we have cosine of mod of x minus 3. So this is 3 minus h minus 3, right? So now we can write limit h tends to 0. We have signum of here 3 and 3 get cancelled, so we have a signum of mod of minus h, right? And now here we have in the denominator cosine of here 3 and minus 3 get cancelled, so we are left with cosine of mod of minus h. So now mod of minus h is simply equal to positive h by definition of absolute value function, right? Because h is a positive quantity, so mod of minus h is equal to positive h. So signum of mod of minus h can be written as simply signum of positive h, right? And since h is greater than 0, so again we'll take this definition of signum function. So signum of h takes the value plus 1, right? So this is an important thing here. So signum of mod of minus h is plus 1, right? So now this limit can be written as limit h tends to 0, and here we have a signum of positive sorry, here we'll have simply plus 1 in the numerator, because signum of mod of minus h is positive 1, right? So here we have plus 1, and mod of minus h is plus h, so we have cosine of h, right? And now we have 1 over cosine of 0, right? Because we can take h is equal to 0 over here, and we have 1 over 1 because cos 0 is equal to 1. So this is equal to 1, right? So now the left hand limit is equal to 1, right? So from this discussion, we see that the right hand limit and the left hand limit both exist, and they are finite, right? So both the limits are finite, and the right hand limit is equal to left hand limit when x tends to 3, right? So we can now claim that this limit, it does exist and it is finite, and the value of this limit is equal to 1, right? So now the limit of this function, it exists when x tends to 3, right? And the limit is equal to 1, right? So here it is important to find out the value of this function at x is equal to 3, right? So let us see what is the value of this function when x is equal to 3. So now if we take f of x is equal to signum of mod of x minus 3 divided by cosine of mod of x minus 3, right? So f of 3 is now equal to signum of, here we have mod of x minus 3. So this is signum of mod of 3 minus 3, and in the denominator we have cos of mod of x minus 3. So this is 3 minus 3, right? So this is signum of mod of 0, and here we have cos of mod of 0, right? Now mod of 0 is equal to 0. So now this expression is equal to signum of 0 divided by cosine of 0, right? And this is f of 3, and now signum of 0 is equal to 0, right? Due to this definition, right? So signum of 0 is equal to 0, and cosine of 0 is equal to 1, right? So f of 3 is now equal to 0 over 1, that is equal to 0. So now we see that the limit of this function when x approaches to 3 is equal to 1, and the value of the function at x is equal to 3 is equal to 0. So we can see that this function is not continuous at x is equal to 3. Viewers, here we know that if a function is said to be continuous at some point, say x is equal to a, if the limit of the function when x approaches to a must be equal to f of a, right? So this is the condition for continuity of a function, right? At some point x is equal to a. So here if we take a as 3, then we see that the limit x tends to 3 f of x, because f of x is this function, so this is 1, and f of 3 is equal to 0, right? So these two quantities are not equal, that is 1 is not equal to 0. So we can say that this function is not continuous when x tends to 3.